Hi, welcome to this lesson. This lesson is all about energy use in a building. Now this is where the crux of energy efficiency of a building can be understood. Now let's look at the ways in which energy is used in a building. Now why is there a need for energy or need for energy in buildings? Well, traditionally we had a system of open buildings. However, as modern we are coming up from the traditional design to a modern design, we are preferring closed design. So if you can look at the picture here, on the left hand side it shows a traditional open building, whereas on the right hand side it shows more of a closed building. So obviously the energy demand for each of the requirements of these buildings are different. Now the building in itself is offering a shelter in a closed structure over time. So most of us work in offices and it's almost our second home. So we know that the energy demand in a home and in an office is different. However, more energy is required in an office spaces because it is kind of giving the requirements for a lot of people as compared to the minimal amount of people who lives in a residential sort of setting. So energy use in a building can be used for achieving thermal comfort, occupant comfort, visual comfort and olfactory comfort. So all levels of comfort needs to be given inside a building so that the energy usage is in its optimum. And also energy is used for the HVAC process, such as heating, cooling, air conditioning, ventilation, and apart from that it is also required for the appliances, the electrical or mechanical equipments in place, water, lighting, and also the artificial lighting and the radiators, air conditioning, etc. So all of these require energy, and that is the corresponding to the energy use in a building. So we need to understand, where does the conversion of energy actually comes from? Or is there a conversion of energy? Yes, there is a conversion of energy in place, where energy sources are divided into two. So one is the primary energy source and the second one is a secondary energy source. Now what are the differences? If you look at the picture on the right hand side, you can see that primary energy includes crude oil, coal, natural gas, even nuclear energy, or waste in itself, or solar, biomass, wind, hydro, geothermal, etc. So from the examples you can actually understand that primary energy is the energy that has not been converted or transformed. So the pure source of energy is what primary sources are. So again, based on the given examples, we can see that even waste can be used as a source of primary energy, and some are renewable such as solar, wind, etc. Some are non-renewable like the fossil fuels and its components. The secondary energy on the other side is the energy that is being converted into the functional forms of energy. So let's look at some of the examples. So the transformation comes from by utilizing of the primary energy into the functional forms, such as petroleum products, manufactured solid fuels and gases, electricity and heat, biofuels, etc. So we are getting a product outside or out of the primary sources, and those are the ones that we call the secondary sources of energy. And finally, in context of a building, we also coin a term called as end energy. Now end energy is the energy which finally reaches the end user. Now when energy is produced, do we get the 100% of the energy produced? No. Why? Because some sort of energy or some percentages of the energy is lost. Okay, so the source energy includes both the site energy and the delivery losses. So most of the losses actually happens when the energy is being delivered from point A to point B. So it can happen during the transmission stages or the distribution stages. So imagine the power is being produced in a power plant. Okay, so it will be that's a source of the energy, and 100% of the energy will be in that plant. But however, for that energy to be used into the other parts of the world or other parts of the building, or to sort of incorporate that energy onto that of a building, it needs to be transmitted, it needs to be distributed, and there some kind of losses can happen. So if you look at the global electricity system energy flows, which is given in trillion watt hours, you can see that the conversion losses from the thermal production is quite considerable, and that of own use of a power plant would be lower, and also the transmission and the distribution losses are also quite significant when compared to the production units. Now, the picture on the right hand side actually shows in different colors the annual per capita final energy use in residential and commercial buildings. So it's a very colorful graph to look at, but the synopsis of this sort of chart is that end use energy consumption has only increased over the period. So if you just look at, for example, the Western European condition and the Eastern European condition, in 1990 it was about 6.6. But whereas it reached a 7 point, kind of final energy use in megawatt hour per capita per year in 2010s. And this was for the residential, whereas for the commercial, the change of factor was from 2.6 to 3.4. So the various colors actually shows you the various parts of the world and the end energy usage, which has only increased over time with the 1990 as a base. So finally, to understand the end use energy consumption, you can see how the commercial and the residential sectors uses energy. So in the residential sector, almost 32% of its energy is used, for example, in space heating, whereas the next factor, 29%, comes from cooking. Whereas for the commercial sector, 33% actually comes from space heating, whereas 32% of it actually comes from cooling. So you can see that depending on the function of the residential and the office spaces, energy uses is different, and it does reflect on the end energy use consumption as well. So kind of giving you an idea of what are the units of it. The end energy units are given in joules. Watts, is there a conversion factor? Yes, 1 watts equals 1 joules per second. And energy consumption units, as we saw in that global end energy unit consumption, it is always shown in kilowatt hours, and that is the SI unit of energy consumption. There is another unit which is known as the BTU, or the British thermal unit, and there is a conversion factor where 1 BTU equals 0.293 watt hours. Thank you.